The following is the second of 2 videotapes featuring Seymour Papert on LOGOWRITER. How to use it and how to think about it. In demonstrating LOGOWRITER, Papert uses the occasion to deepen the viewer's understanding of logo itself.
We ended tape 1 drawing something that can be drawn in pretty well every logo that's ever existed. A 5-sided star. One of the kind of figures that's most commonly associated with logo. What was special about LOGOWRITER was not the product, not the effect we obtained, but the way we did it, the process, the way we thought about it, perhaps. I'm going to pick up this same 5-sided star again and to do it in a slightly different version, using features that LOGOWRITER shares with some, but not most, implementations of logo. Let's have a look at one. This demonstration exercises the LOGOWRITER procedure stamp. The turtle will move, it will put its pen down, it will stamp its own shape on the screen. Let's see how that goes. Notice it's going forward in steps of 20, pen down, it stamps. After 6 repetitions, it does a right 144, and it gives itself a new color. This is a procedure that I've written. By reducing the size of the step, I'm going to get another effect. Watch it. The turtles are now so close that you don't see distinct turtle shapes. So stamp is used as a means for getting a kind of abstract graphics effect. These thick lines. By allowing it to stamp its shape, LOGOWRITER gives the turtle a lot more graphics power. But in addition to giving each turtle more power, LOGOWRITER gives us more turtles. Let's have a look. I'd like to introduce you to LOGOWRITER's 4 turtles. They're called 0, 1, 2, and 3. The command tell allows us to select one or more turtles and send instructions to just them. Tell 0 makes turtle 0 be it, to draw an analogy from popular games, so that any instructions will go to that turtle. Set color 1 changed its color and not the others. We don't have to say tell 0 again. Tell 0 is it, and so the instruction forward 30, wait 20, back 30 will apply to turtle number 0. Tell 1, set color 2, right 45, and you see it obeyed. And now this instruction will go to this turtle. We can tell 2 to become that color and 3 to become red. We can also talk to them in groups or lists. Tell 0, 3 packaged as a list will cause this instruction to be obeyed by the 2 turtles, 0 and 3. Watch, they will change color. And then 1, 2 can be given another color. This use of lists gets around one of the major obstacles in traditional logos. People found it difficult to introduce children to lists at an early stage when they were still doing graphics. The use of multiple turtles makes it very natural to use lists at the earliest stage in logo. Using multiple turtles, one can create symmetry patterns for their artistic effect or as mathematical challenge. Can you figure out, as this pattern unfolds, what kind of instruction produced it? Can you figure out whether it will repeat itself or when? Can you describe the symmetry? More typical uses of multiple turtles are less abstract. It's multiple turtles that made it possible for me to program in LOGOWRITER a version of Pac-Man. These objects on the screen, the Pac-Man, the ghost monsters, really are turtles. They mightn't look like turtles, but they move in response to the same commands. Forward, left, Right. This makes them turtles. To work with turtles in this way, we need to master the art of changing the shape of a turtle. And this is something that LOGOWRITER allows you to do with great ease. I'll illustrate it by going back to the skeleton program you saw at the beginning of the first tape. At the heart of this program is working with turtle shapes. This skeleton is made up of over 24 separate pieces of shape that have been glued together, so to speak. I'm going to describe the whole by focusing in on a few of the shapes, show how some typical ones are made, then how they're put together, and then come back to talk about the whole. I start with the right hand. Here on LOGOWRITER's Shapes page, we have all the shapes that make up the skeleton. I don't want to pause with them at this scale. I'd rather flip over and on the flip side, see blown up versions. Here's number 18, the hand. This is called a shape editor. To show you how it works, I'm going to move to number 17, which is an empty shape. Using arrow keys, I can position that cursor anywhere I like. If I press the space bar, it will leave a little square. If I don't like the position of one of the squares, I put the cursor on it, press the space bar, and the square is erased. In this way, I can draw anything I like, and in fact, the children making the skeleton did draw all the parts by this kind of operation. To show you some of the means LOGOWRITER offers to manipulate such shapes, I'll exercise some of its commands. Set shape, S-E-T-S-H, takes a number and sets the shape of the turtle to the shape corresponding to that number. 18 was the right hand. Watch the turtle. Set shape 19, see the cursor down there, will turn it into the other hand. 20 was the skull, if you noticed. Set shape 0 brings it back to the familiar turtle shape. Set color changes the color. 9 means color blue. 7 makes it white again. Back 20, well, you know what that is. Although the shape's been changed, it's still a turtle and it will move. Pen down stamp. It's been in pen up mode. Stamp will not produce any visible effect, but when now I do forward 20, it moves and it leaves a copy of itself. Not another turtle. It has stamped its current shape on the screen. And this is the way that the turtle draws the skeleton, by positioning itself, setting its shape, and stamping it. You can see the structure of the action as I run the procedure that positions the turtle, sets its shape, and stamps for each part of the skeleton. Next, we'll look at what kind of programming can produce this action. Here's a program, not quite the one that the children who designed the skeleton did in the first place, but a cleaned up one that I'll use to indicate the structure to you, not only of drawing the skeleton using all these sub-procedures for parts, but of working the database part of that program. There are quite a lot of them. There's a lot of work in this. Let's just settle on one of the sub-procedures, the one that draws the skull. Put 080 locates the turtle. We want to name the position for a reason that has to do with finding it for database purposes. Then there's the key drawing act, set the shape 20. You remember that was the shape of the skull. PS, a sub-procedure that does pen down and stamp. And UPS, a sub-procedure that tidies up by returning the turtle in pen-up mode to a central starting place. I'm sure you remember that in the skeleton program you saw in tape 1, you could select a bone, say the skull, and see it change color. I'd like to show you how this works by using a schematic version of the procedure skull. Let's run it. What skull does is send the turtle somewhere where the turtle takes on the shape of a skull and stamps it and then goes away. Now, if we change the color of the turtle and then run the procedure again, the same thing happens, except that it's a blue turtle, in this case, and the skull goes blue. And again, with the yellow turtle, the turtle goes to the same place and stamps a yellow skull's head. Well, by the time you've made your version of the skeleton, you're an expert at setting shapes. An animation will then be pretty easy. The Pac-Man works by setting shapes in rapid succession. There's a shape for Pac-Man with mouth open and a shape for Pac-Man with mouth closed. And you say, set shape this, then you go forward a little, then you say, set shape that, and you go forward a little, and you see the Pac-Man moving along the screen, gobbling as it goes. You can make two men walk across the screen using two turtles, alternating shapes, legs together, legs apart. With this, I leave this chapter of our discussion of LOGOWRITER as a graphics engine and turn to LOGOWRITER as a writer, as an instrument for word processing. We'll exercise LOGOWRITER's word processing capabilities and the terminology we use by removing the split infinitive from this sentence. I'm going to take the cursor, I'm going to move it down, bring it across using arrow keys. I'll do something called selecting the word easily. I'll cut it, I'll move the cursor somewhere else, and I'll paste. Watch how this works. Down arrow key is going to bring my cursor onto the M of made, and then the right arrow key moves it letter by letter until it's placed next to my target word easily. The select key doesn't produce any visible effect, but when I follow it by right arrow keys, you notice that the word easily changed color, showing that it's been selected. What this means, among other things, is that if I hit the cut key, it will be cut out, but not irretrievably. If I use left arrow keys to move my cursor across and then do paste, easily will be put back there. Word processors are made easily to change text. Do you like that? I don't. Let's select easily again, and let's use our left arrows to sweep the cursor across it. We're going to cut it out and move it somewhere else. Oops, I went too far. Doesn't matter. I'll go back again. And you notice that what is selected is not everything that's been touched by the cursor, but only what's between the beginning and the end positions of the cursor. Cut will take easily out. The delete key is just closing up that space. The down arrow brings it down there. I could insert easily immediately where the cursor is, but it would run into text. So I hit the space bar, making a space, and now paste puts easily exactly where I want it. Word processors are made to change text easily. I think that's probably the best position for it. For a demonstration of some other LOGOWRITER capabilities, I use this little letter. Dear Mary, I love this lovely logo. Love, Sue. And I've written a visualization program that makes logo commands appear there rather than in the command center. It makes for better legibility of the whole. What's this command do? It tells the cursor to sweep across the text until it finds the word love. It'll find that one, and then select it. See, it's come up in red. Now, this is a logo command with something really new in it. Repeat for, as if it was going to say forward, right, and so on, but it says CB, which is cursor back. We can move the cursor as a logo command without using the keys. And then delete is a logo command that will delete the letter under the cursor. Watch the 4 letters of love disappear. Now something even newer. Turtle to cursor is a procedure I wrote specially for this. I'll show it to you in a moment. What it does is place the turtle where the cursor is. There's our turtle. Set shape dots heart. Set color dots red. And I'd like to stamp that there. Pen down, stamp, pen up. Now if I move the turtle away, a heart will be left in that position. What if I replace the other loves in the sentence by hearts? I could go through the same sequence again, or I could do something else. I could write a procedure love. I'll show it to you as well. It does exactly that sequence of operations, but with just one command. You see, it put a red heart in place of love there. And if I do it again, it will put a red heart there. And so I've made a new form for my letter. The procedure love doesn't have many surprises. It's just what I said, search quote love, but do notice the formatting. I laid out repeat like this because I do find it clearer. And then there's turtle to cursor, a sub-procedure, which I promised to show you. Turtle to cursor is a procedure I wrote to set the position of the turtle to where the cursor is. Text cursor is a primitive procedure of LOGOWRITER, which is one of two ways LOGOWRITER has to report the position of the cursor. Let's look at both of them. Text pos is 1. Here it says text pos equals 14. That means that the T, where the cursor is the 14th character in this text. You might say it looks like the first, but don't forget that those spaces behind it also count. So do the empty lines above. They have carriage returns. 14 is an ordinal number. It tells you how far along the text the cursor is. Cursor pos is something very different. Here's a list of 2 numbers. That's the format for set pos. This says that that place is -60 along the x direction and +40 on the y direction. Let's move the cursor along. Watch, I moved it 2 positions. So we should see text pos increase by 2. You see it's 16 now instead of 14. And this, instead of being -60, has become -44. It's increased by 16 because each character is 8 turtle steps. Well, I guess you must be noticing that I'm not following the pedagogic route of presenting the simplest things first. I assume I'm talking to teachers who know some Logo and are trying to get from this an understanding of what's different in LOGOWRITER. I assume you'll extract for yourself, after digesting it, what you think should be passed on to children you might be teaching. But it's interesting to see how a child, a beginner, might come to make a product very similar to this letter, but following a very, very different route. In fact, I've seen children do something very much like this, and I'm going to reconstruct the path one might follow. In this reconstruction, Sue uses turtle graphics and word processing almost as independent actions. She's written this text, she's stamped this heart, and now she goes on writing. She leaves 3 spaces for the turtle to stamp a heart, puts LY, and then shifts her attention to bringing the turtle over. This is a heart-shaped turtle, which she positions, and then we'll go back to typing her letter. She positions the comma there with the intention of stamping another heart before it. Well, you get the idea. A child like Sue sometimes settles at a low plateau in use of computers. In Logo, she might drive the turtle rather than write procedures. In word processing, use the arrow keys to make local changes, but not cut and paste and move blocks of text around to make more global modifications to something she's written. One of the ideas behind LOGOWRITER was to encourage more sophisticated uses both of programming and of word processing by putting the two together in one context. I'm going to develop this point by looking more closely at how LOGOWRITER encourages the use of cutting and pasting by putting it in a larger context than just writing. Shape 8 in my Shapes page is this helicopter. Shape 7, same thing with a shorter blade. Shape 6 like that and shape 5 like that. Many children have noted that you can get an animation effect of rotating blades by setting the turtle successively to such shapes as these. But how do you get these shapes? You could make 4 different pictures. It's no enormous job, but LOGOWRITER enables you to do something a little better. You can use cut and paste. For example, there I've cut it. Wouldn't like to lose it, but I can paste it back again. Well, that's no great feat, simply copying it back into the same space, but if I move off to an empty frame and I paste it there, I get my helicopter. And now it's an easy matter to carve off a few squares from the blade to make the other copies. And this is the way in which the 4 copies were in fact made. We see another way in which cutting, pasting, and copying plays an important role in the use of LOGOWRITER by looking at the evolution of this project. A child wished to represent the enormous size of the sun compared with the size of the Earth. And this is a kind of project which in LOGOWRITER, as we'll see by following it through, lends itself to direct drive, top-level programming. First, the child drew this curved line, representing the enormous size of the sun by its small curvature. A lot of thinking was needed to decide just how flat it would be. But also a lot of trial and error was needed to decide exactly where to place it and at what angle. A box is drawn, again some trial and error. The LOGOWRITER command label sun places the word sun where the turtle is. We then move the turtle pen up into this open area representing the interior of the sun. We do pen down, set a color, and fills in the color of the sun. All this, as you notice, is going by direct drive, and the child is accumulating a rather large number of logo instructions. There will be even more. Now we have to put the earth in. The earth is done by setting the shape of the turtle, setting a color, and doing a stamp. The earth is labeled, again by using the command label earth. And so we end up with a rather attractive picture, of which this is only the beginning actually, and with an embarrassing choice. Will we settle on keeping this picture and forgetting about all the logic that went into it? Or will we throw it all away and start again in building up procedures to reconstruct it? LOGOWRITER offers a third way. You see the amount of work by scrolling through the command center buffer. Here are all the instructions. This is what made that picture. And at the end, label Earth, as you remember, was the last act that we saw. What can we do with all this? One thing we can do is to copy it onto the flip side and turn it into a procedure. I do select, and then watch it all go red. When I get to the bottom, I do cut, and there's nothing left. On the flip side, we do paste, and there is all our work. We can easily turn it into a procedure, albeit a messy one, by putting end at the bottom, and at the top, what would we put? To sun, for example. Once we've got it there, we can now run it. But we can also look at it, analyze it, and see where, for example, it might break up into, perhaps that could be called sun, and this part to earth. And so the work can begin of taking this messy code and little by little improving it. For beginners at Logo, one of the ways of getting stuck is becoming so good at direct instructions that the transition to real programming is too much of an effort. It means giving up too much of what one knows how to do. The cutting and pasting operations that we've just seen provide a transition. Another way of getting stuck is becoming very good at writing programs without inputs. Let's focus on this little procedure. A square, forward 50, right 90, forward 50, right 90. And I'd like to draw attention to 2 ways in which word processing can help such a procedure. First of all, we could have made these 4 lines by writing just one selecting it, and then copying it 4 times. Of course, that's not a really important way of using word processing. More fundamental is the situation that arises when we decided, after doing a more complicated procedure, of which this is just a token, that we would rather have put in inputs instead of making it forward a fixed number. Now I'd like you to look at this procedure, to input. It searches for the word forward, and then it inserts dots X times, so that instead of 50, well, why don't I do it instead of talking about it? Let's run the procedure, and let's run it again. You see, forward 50 is turned into forward dots X times 50, and so we go. I could have made this recursive, I could have made a repeat, but the principle is the same. I wanted to keep it clear. We were able to manipulate a procedure, turning it into something different, using a procedure written in Logo. Logo begins with programs that make pictures. And for many people, that's all Logo ever is. But we've just seen an example of a Logo program that makes something very different from a picture. Something, let's say, deeper than a picture. We saw a Logo program that made a Logo program. Many people find this reflexive, recursive quality of programming one of the most exciting ideas in computer science and one of the most exciting contributions of computation to modern thought. Logo has always made it possible to do much more than draw pictures. In fact, it's always made it possible to write programs that make programs. But few children have penetrated into these areas of Logo. LOGOWRITER makes the entry into Logo easier than ever, but it also raises the ceiling. Once inside, it's easier than ever to do much more complex, diverse kinds of things with the computer. And by doing more diverse things with the computer, to find more diverse avenues of expansion of your own mind.
The LOGOWRITER videotapes have been created as an adjunct to the learning system Seymour Papert On Logo. This comprehensive package is designed for ongoing Logo training and is divided into 2 parts. The first, New Mindstorms, focuses on the process and the principles of learning. The second, Logo Hurdles, focuses on specific technical aspects of Logo. Included in the On Logo learning system are 8 videotapes, copyable diskettes compatible with LOGOWRITER or other versions of Logo, and complete print materials. For more information, write Media Microworlds, 12 Clayton Terrace, St. Louis, Missouri, 63131.